Hi everybody, welcome to Knowledge Academy. Today we are going to discuss about how to derive the S matrix for Magic T. The Tamil version on the same topic is already available in YouTube. I have posted it yesterday. You can watch that and get benefited. It may be beneficial to you. The link for which will be provided in the description. Before entering into the video, kindly subscribe my channel Knowledge Academy. Right now, let us enter into the video. So this is the structure of Magic T. It is the combination of both E plane T and H plane T. It has 4 ports: port 1, port 2, and port 3, and port 4. So port 1 and port 2 are the collinear arms, and port 3 is the H arm, and port 4 is the E arm. So the characteristics of Magic T is determined by these arms, by these ports. So here, whenever the power is given, whenever any input signal is given to H arm, the power will be available in port 1 and port 2, that is in collinear arms, and the output power that is available in these ports, in these arms, are equal in amplitude and also in phase, and there won't be any power from port 4. There won't be any power, right? If we give any input signal to port 4, similarly from port 1 and port 2 the power will be available, and they will be equal in amplitude but not in phase. They are opposite in phase, and there won't be any output from H arm. So these are the things we shall discuss in brief about the S matrix of Magic T, and we shall discuss about the characteristics as well. Right. So since it is a four port device, we have the general S matrix of Magic T as a 4x4 matrix: S11, S12, S13, S14. So like that it goes on. So here, when we take a particular element of S matrix, for example this one, the second number, this one, indicates that this is the input port. For example, here it is S13 is given, so this 3 indicates that it is an input port, whereas the first number 1, it indicates that what will be the output at port 1 when the input is given to port 3. So that is the meaning of this one. So similarly, for any element in S matrix, this is the condition, right? For example, S23, what will be the output available in port 2 when the input is given to port 3? This is the meaning, right? So this is the general form of S matrix of Magic T. We have to derive the values of each element one by one. Okay. So as I mentioned earlier, when the power is given to as input to E arm, there won't be any power in H arm, whereas the power in for port 1 and port 2 are equal in amplitude but opposite in phase. Similarly, when the power is given as input to H arm, there won't be any power available in E arm as output, whereas the output in port 1 and port 2 are equal in amplitude and also in phase. So there is one of the characteristics, and another one is perfectly matched and perfectly isolated conditions we have to check here. So perfectly matched means whenever we give a signal to the input port, there won't be any power reflected back to the same port by the junction. So this is the thing. So if a port is perfectly matched, then there won't be any reflected power to the same port when the input is given to the particular port. So here it is clearly indicated that for a Magic T or EHT or hybrid T, port 3 and port 4 are perfectly matched. That is, when we give input to port 3, there won't be any power in port 3. When we give input to port 4, there won't be any reflected power from port 4, in port 4. So that is why S33 equal to S44 equal to 0, right? Okay. And also port 3 and port 4 are perfectly matched. So based on the construction of hybrid T or magic T, whenever we give input to port 4, there won't be any power available in port 3. Whenever we give input to E arm, there won't be any power available in H arm. Similarly, when we give any input to H arm, there won't be any power available in E arm. That is why S34 equal to S43 equal to 0. So these are the characteristics of magic T. So this one I have mentioned already, right? Next, when the power is given as input to E arm, the power at port 1 and port 2 are equal in amplitude but opposite in phase. That is why we have S14 equal to minus S24. Whenever any power is given as input to H arm, that is port 3, the power at port 1 and port 2 are equal in amplitude and phase. That is why S13 equal to S23. Alright. Next, symmetry property. Symmetry property means Sij equal to Sji. Okay, if you interchange the row and column number, then there won't be any change in the value. So that is the symmetry property of S matrix. S12 equal to S21, S13 equal to S31, S14 equal to S41. So that is mentioned here. Similarly, S23 equal to S32, S24 equal to S42. Similarly, S34 equal to S43, that is equal to 0, which we have already derived. So on substituting these properties, we have got this S matrix. We have reduced the S matrix to this point. We have S11, S12, S13, S14. So next, S21 is changed into S12 based on symmetry property, S22 as it is, and S23 is changed into S13. The input given to port 3, that is H arm, equal power will be available in port 1 and port 2. So based on that property, we have changed this S23 as S13. Then S14, when we give input to S24 is converted into minus S14. Similarly, S31, based on symmetry property, it is converted into S13. Again, S32, it is converted into S23. S23 is again converted into S13. Then S33 perfectly matched, so 0. S34, it is perfectly isolated, so 0. So these 4 elements become 0 because of perfectly matched and perfectly isolated properties. Then S41 is changed into S14. Then S42 is changed into minus S14. Right? Alright. Okay. So according to the unitary property, matrix S into matrix S star is equal to identity matrix I. Right? So S star, the complex conjugate of the element. On expanding this, we have got S matrix, we have got S star matrix, that is equal to identity matrix. Then performing matrix multiplication to this equation, to this matrix equation, we have got this. When we multiply row 1 of S and column 1 of S star, we have got this equation. Then row 2 of S and column 2 of S star gives this equation. Row 3 of S and row 3 of column 3 of S star gives this equation. Row 4 of S and column 4 of S star gives this equation. Now we are considering these two equations first to derive the value of S13 and S14. S13 square, according to this equation, S13 square plus S13 square is equal to 1. So 2S13 square equal to 1. S13 square equal to 1 by 2. So S13 equal to 1 by root 2. Similarly, S14 equal to 1 by root 2. Right? Now we are substituting the values of S13 and S14 in this equation first. Okay, and we have got S11 square plus S12 square equal to 0. Similarly, on substituting the value of S13 and S14 in this equation, equation number 2, we have got this equation S12 square plus S22 square equal to 0. On analyzing these two equations, we have S12, the term S12 on both the equations, and the right hand side of these two equations are also same. So obviously S11 and S22 should be equal. And analyzing these two equations, we have got S12 equal to 0. So finally S11 equal to S12 equal to S22 equal to 0. So these are the values of different elements of S matrix of magic T. S11 equal to S12 equal to S22 equal to 0. So on this condition, we have concluded that S11 and S22 are 0. That is, when port 3 and port 4, when two ports of this magic T are perfectly matched, then the other ports will also be perfectly matched, right? And S12 equal to 0. That is, when the input is given to port 2, there won't be any power available in port 1. Similarly, when the input is given at port 1, there won't be any power available in port 2. There won't be any signal traveling through the collinear arm. That is the meaning of this one. On substituting these values in S matrix or generalized equation, we have got the S matrix of magic T like this: 0, 0, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2, 0, 0. So this is how we derive the S matrix of magic T. Thank you for watching my video. If you like my video, kindly comment, like, share and subscribe to my channel once again, Knowledge Academy. And thank you for watching. Thank you.